Dragonfly was designed to be a rotorcraft to explore Titan because it's the right way to explore the Titan environment. It's the right way to make the measurements we need to understand the chemistry of this ocean world. There's sand dunes, there are clouds, you even have methane rain, there are methane rivers and lakes and seas. The organic chemistry in Titan's atmosphere and on its surface may replicate the type of organic chemistry we had here on Earth before life developed. We want to be able to understand how life took the step from chemistry to biology.
We want to give the scientists the chance to be at Titan without being at Titan. We want to give them the ability to sit on Dragonfly and look at Dragonfly, look at Titan from Dragonfly's perspective.
We've been using augmented reality and even mixed reality, different types of immersion technologies across all of our mission areas. We are doing projects today that look at things like perception detection, motion recognition. We're doing things in space missions operations and looking at designs, collaborative design reviews.
We're really not doing anything new except how we're applying the technologies that exist to exploring Titan.
Being there counts. We look at data a lot of times in 2 dimensions. I think we really think that looking at something in an immersive environment like this gives a bigger picture.
Especially for a mission like this where we're interacting with the environment directly, to be able to visualize through the spacecraft's eyes the landing site that we're choosing, or to choose which drill to use on the surface. We can use the VR technology to really be able to put ourselves in that space.
We can bring the data coming down from the spacecraft and pull that into a digital twin sort of situation where you've got this digital asset that is mimicking the physical object that's actually flying.
We can take this technology and allow the scientists and the engineers to take a look at the information of how we're designing it today, what we intend it to do, and make decisions which reduces risk.
This will allow us to plan well in advance how the integration of the whole entire lander is going to go. You can kind of envision when people put their hands down inside, is this really going to fit? And you're doing all this before you have hardware, when you can actually make a change when it matters.
Up until this point, we've never really had an opportunity to bridge that distance between what's happening at the mission design level and what's happening at the mechanical design level.
Let's take a look at the MMRTG inside the cover. So if I pull the cover off, now we can see the MMRTG exposed there. I can see a lot of the thermal loops and things that capture heat and redistribute that throughout the interior of the spacecraft. That's pretty exciting.
Right, so you can see the cameras because we have forward and downward looking cameras so that we're able to take images not only when we're on the surface, but when we're in flight. So we'll be able to look down at the terrain that's beneath, it's going beneath the rotorcraft as we're flying from landing site to landing site.
There it is above us.
Yep.
It's absolutely a game changer. It's changing the human relationship to data. It's changing the human relationship to how we interact with information.
It's a very valuable tool for operations planning in advance, but also for operational decision making in real time when we're acting on the surface of Titan.